So this is homework 3, number 1. And it says the electric field strength is 50,000 newtons per coulomb inside a parallel plate capacitor with a 2 millimeter spacing. So we know that electric field is 50,000 newtons per coulomb, and it's inside a parallel plate capacitor. So this is a parallel plate capacitor. It has 2 equal but opposite plates. So this is a positive charged plate, and on the other side is a negative charged plate. And it says that it has a 2 millimeter spacing. So this distance is 2.0 millimeters. And it says the proton is released from rest at the positive plate. So here's a proton, and it's released from rest. And since the proton is attracted to the negative charge, it will move this way. And so this is V initial, and this would be V final. And now the question is asking, what is the proton speed when it reaches the negative plate? So let me write a list of known and unknowns. So we know that proton speed finally is what we're trying to solve. So VF, and the D equals 2.0 millimeters. V initial is 0 meters per second because it's released from rest, and E is 50,000 newtons per coulomb. And so now we can use the equation delta K is equal to delta U, which is equal to 0. Delta K plus delta U is equal to 0. And delta K is kinetic energy, delta U is potential energy, and we know that with the conservation of energy, both of them should add to 0. And we know that delta K is equal to K final minus K initial, which is also equal to 1/2 mv final squared minus 1/2 mv initial squared. And mv initial squared is 0 because v initial is 0. Delta U is equal to negative work, which is equal to negative force times distance. And to make it from vector to scalar, we do negative QE times distance, which is also equal to negative QED cosine theta, where cosine theta is equal to 0, or is equal to 1, because cosine 0 is equal to 1. And so this is just equal to negative QED. So now we can plug in this and this into this. So it's 1/2 mv final squared minus QED is equal to 0. And so we can solve for VF. VF is equal to square root 2QED over m, which is just equal to 1.38 times 10 to the 5 meter per second.